Alright, this lesson is going to focus on calculating the molar mass of a compound. And we've used the periodic table a lot in previous lessons, and this is the basic format of the boxes on your periodic table. And as we've talked about before, you have your atomic number at the top. So for oxygen, the atomic number is 8. You have your chemical symbol in the middle, so O stands for oxygen. And then you have the number that we're going to focus on today, which is the mass number. Now the mass number tells us the mass of 1 mole of the substance. So in this case, 16 grams is how much 1 mole of oxygen weighs. Now a mole, if you remember, is just a unit of measure. 1 mole equals 6.02 times 10 to the 23rd. Now that's the same thing as a 6 with this many zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So a lot of zeros. But it means the same thing as saying 1 dozen equals 12. So when we talk about chemistry, what we're looking at is if I had this many atoms of a particular element, it would weigh this much. It would have a mass of that many, 16 grams in the case of oxygen. So if you want to find the molar mass of an element, it's as easy as looking on the periodic table. It's the mass number. So oxygen had a molar mass of 16, sulfur 32, sodium 23, chlorine 35, and etc. Just look at the periodic table. If you want to find it of a compound, we have to add the pieces individually because every compound cannot be listed in a table with its molar mass because there's just too many compounds. So in this case, we'll start with an easy example of sodium chloride, NaCl. And sodium chloride is broken into two different elements, sodium and chlorine. So the first thing I want to do is look and see how many of each one do I have. I have 1 sodium atom and 1 chlorine atom making up this compound. So now I would look back to my periodic table and find out that sodium has a molar mass of 23 grams per mole, and chlorine has a molar mass of 35 grams per mole. So if I want to know the mass of sodium chloride, I just add the two together. So the molar mass of sodium chloride is equal to 23 plus 35, which equals about 58 grams per mole. So we could try a harder example as well. In this case, I have sodium sulfide as the chemical that we are going to study. And again, this compound, sodium sulfide, is divided into two elements, sodium and sulfur. So in this case, again, I'm going to start by listing the different elements. I have sodium and I have sulfur. And again, I look up the molar mass on the periodic table and I find out that sodium has a molar mass of 23 grams per mole and sulfur has a mass of 32 grams per mole. Depending on your periodic table, these numbers might be a little bit different, but this is a good approximation. Now, the other thing I have to look for, again, is to see how many of each element do I have in this compound. And if I look to sodium, I have 2 of them. I still only have 1 sulfur. If there's no number listed here, we assume there's 1. But I have 2 sodium. So really what this compound looks like is Na combined with a sulfur combined with an Na. So I have to account for all 3 of those things. So the easiest way to do that is, again, I'm going to find a total, but I'm going to do 23 times 2, because I have 2 sodium, which equals 46, and then plus 32. So the molar mass of sodium sulfide is going to equal 78 grams per mole. Now, of course, you could also get that by doing 23 plus 23 plus 32, which again would equal 78. Either way is acceptable. You just have to find the way you like to solve the problem and go from there. Okay, so this is definitely going to be our hardest example. Right now we have a compound called aluminum carbonate, and aluminum carbonate is composed of more than just two different types of elements. So if I look here, the first element that I have is aluminum, the Al, capital A, lower L. I then have carbon, capital C, and oxygen, capital O. Now one thing worth pointing out is there is an element called cobalt, but that is capital C, lowercase o. So if you're going to have a two-letter symbol, one's going to be capital, one's going to be lowercase. In our example, though, both are uppercase, so it's carbon and it's oxygen. Now, the reason why this example gets to be hard is because of these parentheses here and the number 3 on the outside. So really what this tells me is that I have 2 aluminum and 3 carbonates. If I was to draw this out, I'd have a chemical that looked, something like this. 2 aluminums with 3 carbonates going around. So I have to find how many of each element I have. So the first thing I would do is write them out. So I have aluminum, I have carbon, and I have oxygen. I can see from the problem I have 2 aluminum, so I'm going to write 2 here. I have 1 carbon on the inside, but 3 carbonate, so I'm going to distribute this 3. 3 times 1 carbon gives me 3 carbons. Now you can see that again over here. I have 3 CO3, so I have 1, 2, 3 carbons. The other one is oxygen. There's 3 oxygen for each carbonate. I have 3 of them. Distribute across, 3 times 3 is 9. So I have 9 oxygens. So for this example, again, I have 3, 6, 9 oxygen. Okay, so I just distribute across. That way I don't have to draw out all 3 of those individually. Okay, so to figure out the the molar mass of this compound, I need to know how much each of the element weighs. So I look at my periodic table, and I know that aluminum weighs approximately 27 grams per mole, so I have 2 times 27. Carbon weighs approximately 12 grams per mole, and oxygen weighs approximately 16 grams per mole. So now I'm going to multiply them across by the number of each one that I have. So for aluminum I do 2 times 27, which is going to work out to be 54 from aluminum. 3 times 12 is 36, and 9 times 16 would be 144. And I'm going to add all 3 of those together, so I end up with 14, carry the 1, 6, 9, 13, carry the 1, 234 grams per mole. Again, that's the hardest example you would have to be able to do.